Hello, it's Nick again, and I'm continuing to solve genuinely approachable pencil puzzles from Kraken Scripted Discord. This is the ninth one, and it's Roma by Shye. I haven't seen this genre before, I think. So let's look at the rules. Place an arrow into each empty cell of the grid, each pointing in one of the four cardinal directions. Note arrows within the same region may point in the same direction. After all arrows have been placed, starting from any cell and stepping one cell in the direction of the arrow must always eventually lead to a cell with a black circle. So all the arrows in every region must be distinct, and we should end up in black circle. So there can't be like cycles of arrows or arrows pointing outside. Okay, let's look at the example. Yeah, I'm certain I have not seen this puzzle. This puzzle genre, I mean. Okay. I don't even know where to start. I mean, there is a region with two arrows already placed, so there is only two ways to place the remaining arrows, and I cannot place a down arrow here because it will go outside, so I have to place down arrow here and right here. Okay. So now from this point, like, I must be able to reach the black circle somehow, so I must continue up. If I go right here, I go outside. If I go left or down, I will create a cycle, right? So from here, also I cannot go down or right, and I cannot go up because there is already an up arrow in this region, so I go left. I'm going left. Okay, now in this region we have right and down missing. I cannot go right here, so down and right. Okay, so all of the right part like comes to this cell eventually. In this cell I cannot go left because it creates a cycle, cannot go up because it goes outside, cannot go right because I already have a right arrow in this region, so it goes down. This region is of size 4, so there should be all 4 directions in this region. One of them is left, but I cannot put left arrow on the left border of the grid, so left must be here. From here now I can only go up. Can't go down, can't go left, can't go up, so must go right. And only down left. And here my options are left and up. Up is bad, so left. Okay, I did not understand what is going on. Like, I can try all the options for some cells in order, and see that only one option is left, but I do not see, like, what does that mean? I don't know. Let's see the main puzzle. Okay, in this region again there are 4 cells, so 4 directions. So someone has to go right, up and down, left. Similarly here, it's actually symmetric. Here I can't go up, so have to go right. Can't go down in any of them. Somebody has to go left, so it can't be the middle one. So this one goes up. Okay. Now here, any direction but up will create a cycle. And going up. We have to go horizontally, but going right create a cycle. Among those 2 cells, one has to go right, so it's this one. This one goes down. So like in the lower part, everyone comes to this one, and then this one eventually. Among those 2 cells, someone goes left, and can be this one, so it's this one. Now among those 2, nobody can go left, so one goes right and one goes up. This one cannot go right, so it's up, and this one is right. So eventually I must arrive here, because all other arrows near the goal go from it, not inside. Okay, in this region again, nobody can go right. I've already used up, so left and down. Can't go left from here, so it's down, and this one is left. From here, can't go down, must go left. Nobody can go up, so right and down, left, right here, down here. Here can't go up, can't go right, can't go down, go left. This should be right. Yeah. The only other option is up, and this creates a cycle. Well, I still don't understand anything about this genre, but the puzzle is solved. Well, maybe I don't know. Maybe it's just those deductions one by one. The next one is Statue Park by Jovial. This genre I do know, but still, reading the rules, solving the example as usual. Place each shape from the bank given outside the grid, so like those are the shapes we need to place, exactly once, so that no 2 shapes share an edge, and all unused cells form one orthogonally connected area. Rotating and reflecting shapes is allowed. Cells with black circles must be used by a shape, and cells with white circles must not be used by a shape. Note that shapes may be placed that do not touch any black circles. So we need to put those figures in the grid so that everything that is remaining is connected. So this green zone is connected. And black dots must be covered by one of the shapes and white dots are not covered. Let's look at the example. So we can start by just marking the cells that are given. First thing you need to do is to look at the shapes you are given. And here we have standard set of tetraminos, all 5 of them. So all our connected groups will be of size 4. Connected groups of black cells. So if we see black cells that don't have enough yet, so we must not close those components. So those must continue. This green cell must escape. Or we could also say that if we shade this one, this will have size 5, which is bad. So this is size 4 now, and we should stop it. We have some components that we have to continue. This one we need to continue further, and this green one still further. Now we need to put every shape exactly once. We already have this I shape, so we cannot make it here the second time. So it must go up and create this L shape. Creating an L shape is very nice, and it usually happens early in the puzzle because shapes tend to be L-shaped, and now that we know that we cannot use any more L-shaped determinals, that will usually cancel a lot of options. For example, here we must escape. Now again we have 3 in a row, so we cannot shade this one because that would be an I. We cannot shade this one because that would be an L, so it must be a T. We also must escape with greens here. What's left? We have S terminal left and O terminal left. This can't be an O, so it must be S, and there is only one way to do that. And there is only one way to place the remaining O terminal. Now let's look at the main puzzle. So here our set of figures is the same tetraminos but twice. You can start by marking everything that is given. Technically you don't have to do that. I mean, for checker to work you need to mark all blacks. But I prefer all unshaded to be green, so they're visible and it is easier to check connectedness. So this black must escape. Now we have 4. This green must escape. This green must escape still further. This black must escape. Now this green escapes and this black continues. Now it's 4. So we have 1 S and 1 L. You can also mark shapes that you have already covered. But if you do it with black color, then the checker will be confused. The checker basically checks that the black colors are in all the blacks are correct, and all you have blackened out everything that should be blackened out and nothing else. So if you use blacks here, you will have to remove them for checker to work. Okay, let's continue with the puzzle. This black escapes. Cannot shade this one because it would be 5. This green must escape. What else? This green must still escape. Oh, this is a TT terminal. This green must escape. And this green must escape. But also, like, a good way of thinking about connectedness, like our green cell must be connected. We can also say that it means that on the black cells, if we like consider 8 connectivity, like using diagonals also, we shouldn't have cycles because that would be like enclose some green area, and we shouldn't have like parts that connect 2 points on the border, because that would also enclose this green. That might be helpful later. Have one TT terminal. This 3 will be a 4 either with this cell or this cell, and then this one will be a neighboring, will be always green. Probably not super helpful right now, but can unshade it while we are here. This green must escape. This black must escape. Now the next one will be here or here, and so like this 4 will be a group in any way. This one cannot be shaded because if it is, then it will have to escape here, and it won't be a 4 anymore. This black must escape here. So we have another S terminal. So this one cannot be S now because we will have 1, 2, 3. So this is a second L. Now we have 2 L's, so this one cannot be L and this one cannot be L. So we can unshade those options that will make them L. And now this is a second T. And we have first I. Now this one escapes, and I cannot shade this one because again, like that would connect borders. It cannot be L, so it is I. And we need 2 more OT terminals. So this is the first one, and this is the second one. And the puzzle is done. The next one is full Masyu by Tyrgannus. So Masyu is a very, very popular loop genre, and it is it will be a variant that just says that the loop must use all cells. So the rules of Masyu would be draw a non-intersecting loop through the centers of some cells, but here it will be all. The loop must turn on black circles and travel straight through the cells on either side. So for a black circle, it's a turn, but then after the turn, it is going straight for 1 cell more, and here also. So like drawing this like V shape with both lengths, with both, how do you call them? Arms of the shape. So for black circles, it's a turn, and both before and after the turn go straight. For the white circles, the loop must go straight through white circles and turn in at least one of the cells on either side. So for black circles we go straight, but on one of those cells we must have a turn, maybe on both. So yeah, in regular Masyu it would be draw a loop that goes through some cells and also visit all of the circles. And for black circles it is a turn, but before and after it is straight, and for white circles it is straight, but at least in one of the endpoints it must turn. Let's look how it works in the example. I usually start with black circles that are near the border because they usually give more information, but also white circles that are right near the border, they also are unique. So for every white circle, basically we must draw either straight horizontal line through it or straight vertical, and if it's near the border we cannot draw a horizontal line because it would go outside of the grid, so it must go like this. For black circles that are on distance 0 or 1 from border, look, there must be a turn, which means that one leg, yeah, it's called legs, one leg must be horizontal and one leg must be vertical. So there must be a horizontal leg of size at least 2 coming from this black circle, and it cannot go right, so it will go left. And for this black circle, again, there must be a horizontal leg of length 2. It cannot go left because there is a border too close, so it goes right. And the same is true for the vertical. But for this black, it can go either way right now. Right now we are not sure yet. So remember that. This must go further. Also, we know that this is a full puzzle, so like as I said previously, when we have this full constraint, we can start with drawing those corners in all of the corners of the grid. Also, this line that we drew now limits how we can go through this white. We cannot go vertical because that would create a fork. So we have to go horizontal. Now from here we must go down. And like for this white, we can use like the last rule of Masyu, that like we cannot go up here because that would be a white with no turns on either side. So instead we have to have a turn here, and this should just finish the puzzle because of loop constraints. Like I cannot connect those two, and because I have to go through all the cells, that's the finish here. And now let's look at the main puzzle. Start by drawing the corners. Whites on the side go straight, have to turn on one of the ends. Now this black is decided, now this black is also decided. From the blacks on the side, I go like towards the middle. Why is it line? Come on. There is a good line X. Now I can put X's with right click. So I can't go up because I have already gone down from this black. So this goes further. Now this white must turn here. Also, there is nowhere to go here. This white must be horizontal because vertical would create a fork, just like in the example puzzle. Now this white, we must turn on one of the sides. Just continue the loop here. This white cannot be horizontal, so it's vertical. Just continue the loop, cannot close here. This black, just like in the example, must be like this. Continue the loop, can't close here. Also, must visit this cell, and there is only one way to do that. Now this black cannot go down, but also cannot go left, because otherwise we would have to go 2, and that would it would also reach this, but also when there is an open end on distance 1, I already cannot go there, because it will have to turn also in this cell, which is not allowed. So finishing the loop here, and this black is determined. Finish the loop. Continue. This cell only has 2 exits left. Continue the loop. This cell only have 2 exits left, and that finishes the puzzle. It was not harder than the example. The next one is Supersized Norinori by Freddie hand. Okay. So yeah, that's a supersized puzzle. So I'm guessing it's whatever was it, Sunday, Saturday, whatever. Norinori is the name of the genre, and we have already seen a genre that was based on Norinori, Norikabe. So the Norinori rules are super simple, but and it seems that it should be a super easy puzzle, but it's not that. The rules: shade some dominoes so that every region contains exactly 2 shaded cells. Shaded dominoes may not touch. Dominoes may exist in multiple regions but are not required to. Well, that is not part of the rules. That's just some clarification. But yeah, we should shade some dominoes such that in every region, there are a lot of regions here, in every region there are 2 shaded cells, but it doesn't mean that every region must contain a domino. And actually we can see that this region contains 2 halves of different dominoes, and it is true for many regions. So in this example, only 1, 2, 3 regions contain dominoes. On all others contain halves. There is no constraint on green cells being connected. Nothing. Just shade some dominoes. But it's surprisingly hard. Well, obviously not all of the puzzles, and hopefully this will be a genuinely approachable puzzle, so pretty easy. But yeah, I have found that a lot of puzzles in this genre are unexpectedly hard. Let's start with the example. Okay, so the regions of size 2 are super simple. They have to have 2 shaded cells, so we have to shade both. Now we have a domino, so all the we cannot grow it further. Now in this region we only have to cells left. Yeah, and it greens the cells that are like parts of the regions where we already have two shaded cells. Again, we have a domino here, so all of those are like must be unshaded. In this region, we also have only two cells left, and those, as we remember, were like only three regions with shaded dominoes. Now, this cell cannot be a part of any domino, so it must be unshaded. In this region, we only have two cells unshaded, so only two cells left, so they must be shaded. So obviously they will be parts of different dominoes. So for this one, we can either pair it with this one or with this one. In both cases, this cell will be a neighbor, so it will be unshaded. Also, if we use this one, then all those three will be unshaded, and we have broken this region, so we will not do that. Instead, we will use this one. And now in this region, we can only have this cell left. Now this is a domino, and so we can unshade its neighbors. Now in this region, we only have two cells left, and both of them have only one way to continue. Domino, unshade the neighbors. This cell cannot be a part of domino, and we are left with this one. And now for the supersized puzzle. It's so big that I'm blocking a part of it with my camera feed. Well, you can always like make it a bit smaller. Although I should probably like move camera here. Okay. We can start with some regions of two cells. And also like mark all the neighbors they have. Now this only have two cells left, and this have only one way to move from here, and now this one also have only one way to leave. Marking the neighbors. Now those two regions have only two cells left. Again, marking the neighbors. This region has only two cells. Cannot shade this one because it would be a 3. This is a domino. And this one only has one way. Wow, this is all unshaded. That's very cool. This cell cannot be a part of any domino, and now this region has only two cells left, and now this one also. So we have finished this part of the puzzle. And also mark neighbors here. This region, the bottom only has two cells. Must leave like this. This region needs one more and has only one cell left. Use this one. Now this region. In this one. Okay, I don't know if this is helpful, and probably there are easier ways to continue, but I can see that I have to use this cell. If it is not used, then if I want to use this one, I will have to go down from it, and this is not a domino. Otherwise I will have to use those two, and it is again not a domino, so I have to use this one. Okay, so because I have seen this genre before, I know some things. For example, I know that for this L triomino, I cannot use this cell ever. Why is that? Well, if this is a part of a domino that goes like out of this triomino, then those two cells must be unshaded, and that's bad. But if it goes inside, then those two cells must be unshaded, and like similarly if I go here, so this cell must be unshaded. There is kind of similar thing for like I terminals, but like it is okay to like shade the domino like this, but if it was like on the border, then yeah, the oh no, on the border is also fine. But like if for some reason I know that this way of placing domino is bad, then this cell must be unshaded. Right. Okay, so in this big region I have already shaded one cell, so the second shaded cell must like be a part of a domino that is split between two regions. The only way to do that here is like this. Now this is unshaded, must shade this one, let's go like this. This cell cannot be a part of a domino, so it goes like this. And for this region again, like it must be just half of a domino, so it's like here. Now from here I can go left or down. And going left is bad because like it will unshade all the cells, all the remaining cells in this region. So I have to go down. This cell cannot be a part of any domino. Now in this region we only have two cells left. Now in this region we only have two cells left. Cannot shade this one. This must continue down, and this must continue right. Now in this Z region only one cell is left, and we must shade it, and we must also shade its only remaining neighbor. Now in this region we only have two cells left. Also in this region there are only two cells left, so shade them, cannot shade this one. From here go down, and all of this is now unshaded, so this one must continue right, and this one must go up. Now in this region we used one, need the second one, and shade neighbors. From here I cannot go right because all of the other cells in this region will be unshaded, so I have to go down, and there is only one cell left. From here cannot go down because that would mark all of those as unshaded, but then there are only two other cells in this region. Cannot shade this one, so have to go up from here. Have to go right from here, mark neighbors. Among those two cells I can only use one, so the other of three must be used. In this region I only have two cells left, and this one must go down. Now in this region it's not very well visible, but yeah, I guess I have one cell, so I need another half of the domino. It must be like this. Now in this region only one cell left. In this region only one cell left, mark the neighbors. In this region only two cells left, now only two here, now one here. This region already has 1. And this doesn't, so this one needs 2. But if I like draw this domino like this, I can either get like 1 or 3, so it is bad. So this goes up, and now just draw a domino in this region like this. Well, it wasn't very hard, but okay, let's do a couple more. The next one is Overlapping Squares by Eric Fox. Yeah, I think I have seen this one a couple of times, but didn't solve a lot of them. Trace some grid lines to draw squares in the grid. Exactly 1 square must exist of each size within the range given outside the grid. So for the main puzzle it would be 1 through 6, and for example it's 1 through 4. The sides of different squares may intersect each other, but not turn at their intersection or otherwise overlap. So like the endpoints must be distinct, but they can cross like if they go straight at the intersections. A clue indicates the sum of the side lengths of the squares which contain the clue. So like for this 7, for example, it is inside of 3 and 4 squares, so their sum is 7. This 6 is 4 plus 2, those 4s are just 4s, 3 and 1. Okay, let's try the example. So to recap, like we need to draw the squares of given sizes, 1, 2, 3, 4, for example, and they cannot overlap. They can intersect only if both sides go through the intersection, like straight through the intersection, and the numbers given in the grid must denote the sum of sizes of squares that cover this clue. Okay, so 1 is pretty simple. It must be only covered by a square of size 1, and there is only one way to draw a square of size 1 that covers a given square. Now, like no other squares will be able to use those edges. I think on this one also, because like that will if they use those squares, they will have to go through one of the corners of the one square, which is not allowed. Since we have used one square, we only have like 2, 3, and 4, and so this 3 must be only 3, this 4, and this 4, they can be only 4, because like 2 plus 3 is already bigger than that. So the 4 square must contain both of those, but they are like on distance 4 by this width, so the 4 square must go like this. Now this 6 must be 4 plus 2, so we need to draw a 2 by 2 square that contains this 6, but it also cannot go through this corner, and there is only one way to draw 2 by 2 square like this. And now this 3 and 7 must be in the 3 by 3 square, so the sides must contain those lines, and if they go further to the left, something bad will happen, like either well, in any case, okay, this square will contain this corner, which is not allowed, so it must go to the right. Okay, so the example was pretty small. Let's see if we can do something more interesting in the main puzzle. Oh, not we, but Eric Fox did something more interesting for us in the main puzzle. So this 4 must be part of some square, and it cannot be a part of any other square, so the square must have a side of 4. Okay, now this 10 must be 4 plus something, and it cannot be in 2 more squares. Like, in general, if the number is like to some border, or like if we look at a square that contains some cell, there is one side of that square on all 4 directions from that cell. And so from that cell, every square that has this number must like have some horizontal segment above it and some horizontal segment below, some vertical to the left, some vertical to the right. But there are only 2 distinct segments above 10, and so it means that at most 2 squares can cover this 10. So this 10 must be like a 4 plus 6, and so this 6 square will be like one of like the horizontal sides must be on those lines, and it cannot go to the left of it because otherwise it will contain this 4, which is not allowed. Like, this 4 must be just a 4. So the 6 by 6 square has only one way to be drawn. Alright, now those 6s must not be covered by anything else. But this 8 must be covered by 2 more, so it must be a 2 by 2 square, and again we can see that it cannot pass through this point, otherwise there will be some overlap of squares, and there is only one way to draw 2 by 2 square that doesn't pass through this corner of the cell that it must cover. Okay, so we have 2, 4, and 6, all the even sizes. Now we need all the odd sizes. 1, 3, and 5 left. And so this 12 already has 6, so it must be 6 plus something. It can't be just one number, so it must be at least 2, but it can't be all 3 because that would be 15. Right? So it will be 2 numbers, and only 1 and 5 fit us. So this 12 must be covered by 1 and 5 apart from the 6 it already has. So 1 must be like this. And the 5 must also take this 5. So the vertical lines, if it is here, then the other one would be on distance 5, which is here, which is good. But if it is here, then the other one would be here, which is bad. So the vertical lines must be on those lines. It must go higher to not touch those corners. If it goes right here, then the lower side will overlap with this lower side, so it must go even higher and even higher than that because it cannot overlap with this square. So this is the 5 by 5 we want. And now the 3 left. We need to cover this square. We want to not cover any other clues. So this 6 is like the one I'm worried about. And we also need to overlap with this line in particular. So the lower bound cannot be here because otherwise the upper side will overlap with this line. So it must be like here and here. So it cannot go to the left because it will take the 6. And thus, like, the only way to do this is like this. Okay, that was a nice puzzle. And let's do one more. February 14th, Chocona by Shye. Yeah, some Valentine's Day humor. Today I made you a chocona. Shade some cells so that each orthogonally connected area of shaded cells is in the shape of a rectangle. Yeah, that is like a thing about like there are other genres that use like chocolate bars, and usually it means that the shaded cells will be rectangles. The famous one is Choco Banana, which is, I guess, like this Chocona plus another genre. Okay, so we're shading some rectangles. Regions with numbers must contain the indicated amount of shaded cells. So we have regions, and they just tell us how many we need to shade in this region. Okay, seems simple enough. Nothing about green cells being connected, nothing about green cells at all, just shade some rectangles, and the regions must contain a given number of shadeds. Okay, so first we look at like maximal and minimal regions. So this 5 must mean all shaded, this 0 must mean all unshaded. This must be a rectangle, so it must include this cell, but it cannot go further on the right because it will have to take both of those two, and this will be at least 3 for this region, which is not allowed. So this rectangle must stop like its expansion to the right, and thus like both cells on the side are unshaded. It cannot also go down because that would take 3 cells in this 2 region, which is not allowed again. And now we have only 2 cells left in this 2 region. This 4 region looks interesting, but yeah, I guess you can do either one of those. This one is kind of easier by the rules. Like I cannot stop, like I cannot not go down in this rectangle because otherwise those 2 will be unshaded and I only have 3 left. So I have to go down, and I have to go down again for the same reason. Now this rectangle is bordered on all sides, so those must be unshaded. Now in this 4 region only 4 cells left. This rectangle cannot go up from it, but have to make 1 more shaded cell in this upper right region. But let's go back. Yeah, from here you could also just solve this region. I want to say that I cannot go right here. Why is that? Well, if I go right here, maybe I can go right even further, but then this rectangle will have 2 unshaded neighbors in this region, like this, or like this. So both cases are bad, so cannot shade this one. But then it is unshaded, then I have to shade everything else in the region, and this cannot be rectangle anymore. So this one must be unshaded. It means that all those 4 must be shaded and like the upper part is solved as before, and the lower part is solved also as before. But just for some reason, like I saw that before I saw the for down. Okay, let's solve the main puzzle. 9. Fully shaded. Cannot extend down, cannot extend right because of this one region. I would take 2 and 2 in both cases, so those must be unshaded, then this one is shaded. On the left, I have to extend here, because otherwise in the 3 region I won't have enough cells. Okay. This 5 is just a 5 cell region, and I have to continue it to a rectangle, and now I cannot extend it to the right or down because this will be 6 at least shaded for this 5 regions. So all of those are unshaded. Now in this region I only have 4 left, all of them are shaded. Continue to rectangle. Cannot extend to the right because it will create 3 shaded in this 2 region. Okay. What else? Oh, this rectangle means that this one is unshaded, and now in this 3 region I need a third shaded, so I have to extend this full rectangle even one more to the left. Now I have 2 shaded in this 2 region, so it finally stops. In this 3 region, only 3 cells left, have to shade all of them. Cannot take this cell because this is not a rectangle, and like it cannot be a rectangle because it has an internal angle. So like anything I do further will not make it better. So this one is unshaded. If I don't extend this rectangle to the left, then this region will not have enough cells, so I do. Now this one is unshaded, and for this region to have 3 I have to shade this one, and therefore extend this rectangle upper. Cannot take those 2 because that would be 3, so this rectangle stops here. Now this region has only 1 cell left, I'm taking it. Cannot extend this big rectangle even bigger up because that would create this internal angle. So all of those are unshaded. This 2 region needs 2 shaded. Cannot take this one. This 2 region already has 2 shaded, so all the remaining cells must be unshaded. Is something wrong? Oh, right. The border of the region was here. Okay, disregard the last part. No, those are still unshaded. So from those 2 I have to take 1 shaded. How did I understand that something is wrong? Is because like this 3 region could be finished in 2 different ways, like this or like this. So the solution is not unique, which is can't be right. Okay, in this region 1 cell left and it must be shaded. Then I cannot extend this rectangle because of this bad angle. So now this has to take the last cell in the region. Now this rectangle cannot go up. Now in this 2 region actually this must be shaded. And I mean I can see that this is the solution. why there can't be a different solution? Well, if I take this cell, then this must be unshaded, and this is not rectangle, so this must be unshaded, so I have to take this 3. But yeah, in the endings, it is usually easier to just like see how the solution must look like, rather than make logical deductions, like prove that something doesn't work. It is easier to see what does work. And good puzzlers, they might see it like for the whole puzzle. Okay, the solution must look something like this, and then just fix local parts to satisfy all the limitations. I cannot do this. I try to solve logically, but that takes time. Right, so that was the third episode of me solving genuinely approachable pencil puzzles. Today we did 6 puzzles in an hour, which is much better than before. Thanks for watching, and hopefully see you next time.